Hey there! Happy Monday, pre-algebra. Before we get started, we have 8 weeks left. Here, that's the countdown until the end of the school year. But here is our joke for today. What do you call a guy with a rubber toe? Well, a guy with a rubber toe, you'd call him Roberto. There it is. Alright, I'm on page 507 in your textbook. You may want to turn there. I think this will be a refresher of something that you have already learned. So hopefully this video will be nice and short. The assignment will be pretty easy, hopefully jog your memory. And this is something that you will most likely see on the SBA. So just a reminder, next week is when we'll start the SBAs. The Monday of next week is pretty normal classes, but then Tuesday, Wednesday, Thursday will be SBAs. And then Friday, a few of you will leave to go for NYO. So, we are talking about scientific notation. How do we write numbers in scientific notation? So, the term that I'm going to be using in the math term is standard form and scientific notation. So, an example of a number that's written in standard form would be 12,760,000. And then to write that in scientific notation, what I have to do is I have to count my decimal places. So here's where my original decimal place is, and I just want to have one whole number. Or, like, I'll just watch. So I'm going to move my decimal place 1, 2, 3, 4, 5, 6, 7. So that's where I want to have it. See how you want to just have one whole number. So I'm going to have 1.276, and then we do this thing times 10, and we count. Our exponent is going to be how many times we moved our decimal. So we moved it 1, 2, 3, 4, 5, 6, 7, so 10 to the 7th power. That would be scientific notation, where you see something like 1 times 10 to a specific power. So that's scientific notation. So the first thing is, how do we turn our scientific notation numbers and express it in standard form? So take a look at the bottom of the page. We have 2 times 10 to the 3rd power. So the trick is, when we see it written like this, scientific notation, we need to place our decimal point. So right now our decimal point for our number is right there. So we're dealing with 2 point something. Now we need to look at our exponent. This determines how far we move the decimal place. So we're going to move the decimal place 3 times. And just to kind of make you think, if we move, are we going left or are we going right? Think about, is this number a pretty big number or a smaller number? So when I think 2 times 10 to the 3rd power, yeah, it's going to be bigger than just 2. So I'm not going to be moving left, because here I'm making the number smaller. I'm moving the decimal there. That's not what we do. So we need to move our decimal place 3 places to the right. That's going to make our number bigger. So I'm dealing with 2.0, and I'm going to move it 1, 2, 3. So draw the decimal and then write in the zeros. So that's going to be 2,000. That would be what form? Standard form. That's right. Standard form. Okay? Now, let's look at something else. We're going to have 3.25 times 10 to the negative 4th power. Now, we've already talked about negative exponents. Which direction are we going to go? Left or right? What do you think? Why don't you point at the screen? That's right, we want to go left this time. So we're going to go left a number of 4 times. So I'm going to go 1, 2, 3, 4. Put our decimal, we got a 0, 0, and 0. So to write this number in standard form, I would then need to see 0.0000325. Okay? This is what I want to see in your work. I'm going to require it. If I don't see you actually moving and doing the little squigglies here, it's not going to count. I'll say that again. I need to see this. I want to make sure that you are doing the process and this is how you solve it correctly. So I need to see you're counting your spaces. Okay, turn the page. We're going to move on. So now we're going to work backwards. What about if we're given a standard number, standard form, how do we turn it into scientific notation? So our first one is 4 million. Alright, so again, this is where we just simply work backwards. Find our decimal place, and we want to move our decimal place so that we just have one whole number. So I'm going to 1, 2, 3, 4, 5, 6. That's where 4 would be our whole number. So then it would be 4 times 10 to the 6th power. I'm just checking in my book. That is correct. Alright, now what if we have a small number, say like 0.0072? Well, we do the same thing. We got to move our decimal so that we just have one whole number. So I'm going to go 1, 2, 3. Alright, so I'm going to have 7.2 times 10 to the 3rd power. Oh, negative 3rd. Got to have that negative symbol so that we know that we are working with smaller numbers. Okay. Last thing, and this is kind of going with the example at the bottom. If you remember what happens when we multiply exponents, it's going to work the same way with our scientific notation. So here's the example. If you look at the real world example number 3, at the bottom of page 508, it says scientists estimate that there are 3.5 times 10 to the 6th number ants per acre in the Amazon rainforest. If the Amazon rainforest covers approximately 1 billion acres, find the total number of ants. Write in scientific notation. So they're telling us that there's a certain amount of numbers of ants per acre. Alright, that's a big number. I think that's actually like 3 million. 3 million ants per acre. Now it's telling us, what if there's 1 billion acres in the rainforest? So what we're doing is we're really doing multiplication. So we have 3.5 times 10 to the 6th power times 1 times 10. Let's see, 1 billion is... Yep, that's 1 billion. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 1 times 10 to the 9th power. Alright. So just like we do with our multiplying, we want to multiply our base numbers. So remember, our base numbers would be kind of what is our exponent being attached to. So it's attached to these numbers. So we're doing 3.5 times 1. So we're going to end up with 3.5 still. We're still going to have times 10. Now remember, when we multiply exponents, we add them together. So 9 plus 6 is 15. And that, gentlemen, is our answer. So if you want to double check in your calculator, make sure there should be a special form. Actually, I don't know if your calculators have that. So don't worry about the calculator. Let's just deal with a written form. So for an example, if we were going to see 2.2 times 10 to the 5th power times 4 times 10 to the 7th power, we're going to do our base numbers. So we get 4 times 2.2, which is going to be 8.4. Yep. Hold up. I actually need to multiply this. 2.2 times 4. 4 times 2. 8. 4 times 2. 8.8. Sorry. 8.8. But I think you get the idea. We need to multiply the base numbers first, and then we add our exponent. So 5 plus 7 is 12. Okay? And the same thing with division. If you run across a division problem, you are going to subtract your exponents. All right, I think that's it. If you have any further questions, please raise your hand for help. Remember, today we are working a little bit more quietly. We're trying to get in that test prep mode. So work hard, and I will see you in real life.